We are going to solve the problem to convert the binary search tree into a sorted double linked list. So the final result will be a doubly linked list that link in order, that is 1, 2, 3, 4, 5. So we can do the in order traversal to traverse from the first one, then second one, third one, fourth one, in order traversal. And then in the process, we can keep checking the previous element. And then at the current element, we can link to the previous one. We can connect the current one to the previous one. And then after the traversal, the elements will be connected together in order. So let's start coding. Let's say we because during the process we will lose the reference to the very first one. So maybe we need a dummy node that we can always refer to. So let's create a dummy node. So okay, we create a dummy node, and also we need two variables. Let's say that points to the previous one. So let's point to dummy, and then we need another variable called pointer. I point to the current one, and also we need a stack that is used to do the in order traversal. So let's write down the in order traversal. We will keep the loop if pointer exists or the stack is not empty. We'll keep doing. Okay. So because the pointer will always point to the root of the tree, we will put in order traversal we will do the left and then the root. So when the pointer was point to the root, we will need to move this pointer to the stack. So if pointer exists, let's put it to the stack. And then we point the pointer to the left one. Okay, then this iteration was finished, then go to the next. If the other one still have the pointer is still exist, then we will keep doing. If the pointer always point to the root, we will put the root to the stack, put to stack, put to stack, until the pointer is point to null value. So when the pointer was pointing to the null value, we will pop from the stack and start processing this node. Okay, so in this case, pointer is no value. So let's pop from the stack. Let's call it node. Okay, so we have the node. Then we will point. Okay, so we have the node, and the next So the next node will be the right node of the current node. So let's point to the node dot right. So we find out the first node, and then let's have some comment. So this here will be the starting block, starting to process node. And here is the next iteration. Okay, so we have the next point, and then before going to the next, we need to record the current one to the previous. Okay. So by doing so, we have already finished the in-order traversal. Okay, so other than the in-order traversal, we also need to connect the current one with the previous one. So let's have a function called connect, which will connect current one to the previous one. This is the connect function. We'll take two parameters, R1 and R2, which means the root 1 and root 2. Then, let's say R1 is the previous one, R2 is the current one. So R1 is the previous one, R1 dot right to R2, R2 dot previous, up to the left. Okay, so here we connect the previous one and the current one. Okay, so after doing this process, and each process we connect current one to the previous one, current one connect to previous one, current one connect to previous one, current one connect to previous one. Okay, so after we break the while loop, the variable of pre will point to 5, and also we need to connect the 1 and the 5. So after the loop, we need to connect the previous one, which is the 5 previous one, and the current one. Here is a node called Doubly, and we set the previous one to the dummy in the beginning. So for the first node, it will connect to the previous node, which is the dummy node. So we can refer to the first node by using dummy.right, which is dummy.right. Okay, so we connect the 5 and the 1. And finally, we need to return the head, which is the 1. Okay, so let's test. Oops. Previous two. Okay, so the answer seems to be correct. Okay, Okay, also we need to handle the edge case. If the root is no value, we need to return null. Okay, so let's try the solution.